Good evening, all. Today, my topic is VPN Security. My name is Sanskriti Singh Gehlot. I am here to give presentation on VPN Security. Topic to be covered. These are the topics we will going to cover in this meeting. So, first of all, I would like to talk about understanding a virtual private network. Most of the organization has its office located at different location around the world. There is a need for establish a remote connection between these offices as a result. Previously, remote access was established through lease line with the help of dial-up technology lines such as ISDN, DSL, cable, modern satellite and mobile broadband. However, established remote connection with these lease line is quite expensive and the cost rise when the distance between the office increases. To overcome the drawback of traditional remote access technology, organizations are adopting virtual private network VPNs to provide remote access to their employees and distance office. Now let's talk about features of VPN. Establish a connection between the remote system and LAN across an intermediate network such as internet. VPNs allow cheap long distance connection over the internet since both endpoints require a local internet lines which serves as a free long distance carrier. VPNs use tunneling protocol. VPNs use encryption to provide a secure connection to the remote network over the internet and protect your communication. They provide virtual access to the physical network as if you are physically located in the office. There are some advantages of VPN. VPN are inexpensive. They provide a framework for corporate internet and external ensured secure transfer of data. VPNs allow you to access both web applications and website. There are some disadvantages of VPN. Designing and implementing VPN is a very complex thing. Reliability depends on the server provide that you choose. How VPNs work. This is a pictorial representation of working of VPN. The packets are encrypted at the client side and the packets are decrypted at the VPN server. For example, when a client with a VPN connection enabled browser youtube.com, this outbound traffic is encrypted at the client side. The encrypted data is then sent to the nearest VPN server and passes is to the gateway server. Here, the data is decrypted and sent to the server hosting youtube.com. When youtube.com sends a reply request, the VPN server performs the reverse process to the outbound traffic. Now, VPN components. There are four main architecture consist of VPN component: VPN client, network access server, tunnel terminating device, and VPN protocol. Now, let's talk about VPN protocol. The following diagram show the uses of various VPN component in the remote access VPN. Typically, remote access VPN connection is established as follows. The remote user propagates a PPP connection with an ISP NAS through a PSTN. The packets sent by the user are sent to the tunnel connecting NAS and VPN server after authenticating the user. The packet is encrypted before placing it in the tunnel. The location of the VPN server depends on the model used for the VPN implementation. The VPN server accepts the packet from the tunnel, decrypt and send it to the final destination. Next, different VPN types and technology. First, client to site remote access VPN. Very host using remote access need to have the VPN client software installed that wraps and encrypts the data before the host send by any traffic over the internet to the VPN gateway. After reaching the gateway, the data is uncrypted, decrypted, and passed over the final destination in the private network. The gateway performs the reverse process in order to send the data packets back to the user. The remote access VPN consists of two types of component. Network access server or client software. This is a pictorial representation of remote access VPN. Next, site-to-site VPN. In site-to-site VPN, the outbound traffic is passed through the tunnel to the VPN gateway. The data packet in the outbound traffic are encrypted at the gateway and are passed through the tunnel over the internet. The traffic is sent to the nearest gateway to the target location. The nearest gateway decrypts the data packet and they are then forwarded to the final destination. The site-to-site VPN consists of two types, internet-based or external-based. This is the pictorial representation of site-to-site VPN. Next, hardware VPN. There are some advantages of hardware VPN. Provide load balancing, especially for large client load. There are also some disadvantages of hardware VPN. It is more expensive than a software VPN, more useful for large business organization than for smaller one. It has less scalable. This is a pictorial representation of hardware VPN. Next, software VPN. There are advantages of software VPN. Minimize the cost of additional hardware purchases. It is easy to deploy and does not charge the target network, and also more scalable. There are also some disadvantages of software VPN. Increased processing task for device implementing the VPN. Security is an issue and respond to more attack as they need to share the server with other server and operating system. Next, core functions and technology. First of all, encryption. The encryption helps secure the data passing through the network. The sender encrypts the data passing through the network and the receiver decrypts the data. It's required no encryption on the communication link between a dial-up client and the internet service provider. And the process of encryption takes place between the VPN client and the VPN server. VPN encryption technology are triple DES algorithm, secure socket layer, and open VPN. This is a pictorial representation of VPN encryption. Next, authentication. A VPN employs three kinds of authentication: user authentication, computer authentication, and data authentication. Authentication techniques used in VPS are Kerberos, PAP, SPAP, CHAP, MSCHAP, and EAP. Next, VPN technologies. First, trusted VPN. The requirement for the trusted VPN are any changes in a part of VPN can be made only by the trusted VPN. All routing and addressing method needs to be described before creating a trusted VPN. Only VPN provider can inject, change, or delete the data in the part of VPN. Next, secure VPN. The main requirement for secure VPNs are all the data packets in the traffic are encrypted and authenticated prior to sending it to the client. The client and the server need to be mutual understanding before initiating the connection between each other. Confirm the security of the connection for unauthorized user. Next, hybrid VPN. Main requirement for hybrid VPNs are there should be a clean differentiation between the trusted VPN and the secure VPN. This is a pictorial representation of hybrid VPN. Next, VPN security and risk. First of all, VPN fingerprinting. A VPN fingerprinting techniques allow the attackers to access useful information such as the type of connection implemented, device used, and operating system deployed. Some systems, such as Cisco PIX, potentially reveal crucial data like the general types of device deployed for the building the network, while other systems display the software version details. Next, username enumeration vulnerability. The identity payload contains the username and the hash payload contains the password. Certain flows identified in the flow of packets are as follows. Free VPN server only respond to valid username. Free VPN server respond with an error to incorrect username. Few VPN server respond to valid and invalid username. The hash payload process uses invalid username with null password. Next, offline password cracking. When the VPN server gives a response to the client, it consists of the contained like a key exchange, identity header, and the hash. The server responding with the hash query from the client is called a hash responder. Since the responders are not in the encrypted form, the attackers get access to the hash responder and uses a pre-shared key to perform the attack. The attack is offline, and as a result, the VPN log server does not create any log entry. The attack does unnoticed by the network defender. Next, man in the middle attack. Attackers may use insecure authentication protocols such as IKE to perform man in the middle attack or a VPN. And attackers encrypted the communication between the client and the server and obtain the client authentication to the server. The attackers then utilize these authentication credentials to log in and access the VPN server, allowing for computer allowing for complete control over the VPN server. Next, lack of account logout. There are the few VPN that do not provide an account logout feature, and this enable user to perform login attempt repeatedly. Attackers can take advantage of the lack of the account logout feature to gain account credential and it reduce the security of the account detail. Next, poor default configuration. The selection of weak authentication mechanism such as IKE aggressive mode with a pre-shared key allow attackers to gain authentication credential. It must be ensured that mechanism selected for protecting VPN has a certified based authentication mechanism enabled. Now, VPN security. In VPN security, first of all, we will like to talk about firewalls. Firewalls can be used in two ways with the VPN. The VPN server is attached to the internet and the firewall is located between the VPN server and the internet. Here, packet filters are added in order to allow only one VPN traffic to and from the IP address of the VPN server. The firewall is attached to internet and the VPN server is located between the firewall and internet. Here the firewall has input and output filter on the internet interface in order to maintain traffic and passage of traffic to the VPN server. This is a pictorial representation of firewall. Next, IPsec server. The IPsec server consists of two types of encryption mode. First, transport mode. In transport mode, IPsec encrypt the IP payload through an authentication header AH or encapsulating security payload ESP header. The IP payload can be a TCP segment containing TCP header and the TCP segment data, UDP message containing the UDP header and the message data, and ICMP message containing ICMP message and ICMP message header. Tunnel mode. In tunnel mode, IPsec encrypt both the IP payload and header to protect an entire IP packet by encapsulating it with an AH or ESP header and an additional IP header. This mode is useful for protecting traffic between different networks and it's primarily used for interoperability with gateway. Next, AAA server, authentication, authorization and accounting. The authentication protocol used for an AA server are Radius, TACACS Plus, RSA Secure ID Window T, Carbos and LTAP. Next, remote access dial-in user server. In Radius, the VPN server interacts with the Radius server. Once the user attempts a connection, the Radius server authentication the user using their credential. The user is granted access if and only if the user provides the correct credential and has a dial-in access. The Radius server sends a Radius message to the Radius client in respect to the request for authentication. This is a pictorial representation of Radius. Now let's summarize all things. In this module, we have learned the need for establishing the VPN network, different type of VPN components, technology, topology, VPN security risk, VPN security and lots. Now, I would like to wrap up my presentation. Thank you all.